So now this is about front view and top view. So based on front view and top view, we need to create the model. Okay, that is about isometric view. Now he is saying he is getting only one dotted line. So instead of two dotted lines here. Okay, right? Now these two hidden lines are of an rectangular cut at the bottom side. Okay. So we have an only height hidden line here, but in top view we have a width hidden line. Okay. So shall I draw that one with a simple sketch instead of a making model? Shall I draw in an yes? Okay, I will draw in an PPT. You can just look out. So now this is actual isometric diagram. So now this indicates front view. This is what top view. Okay. So you won't get this line here. Okay, you won't get this line. So if you look out, you're going to get the visible portions. Okay, that is what in front view. Okay, this is what clearly visible. You will go to get in one hidden line here. This hidden line because of the cut portion here. Okay, because of cut portion, right? So when you look out the top view, if you look at top view, okay, so what will get? Usually this is a top view, right? I think doubt is clear, Gokul. How to read the diagrams are. So you need to understand the basic concepts first. The projection of rectangle block, square block, cylinder, sphere, as well as truncated cylinder in all three directions. Okay, if you gone through that one, little bit easy to read the diagrams, right? So for this one, we have some other time. We'll discuss how to read the diagrams. Okay? So now I'll go for one future. Okay, that is what elongated hole tool. Elongated hole. Okay. So for your reference, yesterday I have drawn two circles. Okay, and we have drawn horizontal lines. Okay? I have trimmed out this portion as well as this portion. So what remains? You got an slot here. Okay. Now in CATIA, you can draw this type of holes. Okay. Either it may be straight hole, either it may be arc shape hole, using directly this elongated hole option. Okay. Using directly this elongated hole option. So now I'll load one diagram. I'll just open one diagram and just okay. Now you can just have a snap of this one. Okay, you can have a snap of this one. Okay, so I will take this as a snap. Now this is the two holes here. One is a hole of arc shape, another one is a hole of a straight shape. Okay, so one is a circular hole. One is circular hole. So let us go for first the diagram here. It has all corners as an fillet here. That is what corner has a radius of 10 mm. Okay? Is it clear? It has a radius 10. It has a radius 10. It has a radius 10. So exactly it is a square of 200 by 200. Now I will start to cat here. Now I will start cat here. Okay. Start mechanical design, part design. Okay. Now you click on sketcher. Then you go for front plane. Okay. Now you just click on this rectangle. Okay. Rectangle. So make in first corner. So as you need to draw the square, you just type 200 by 200, right? Then go for fit option. Now you made an outer loop. You made an outer loop of the diagram. Let us look out. It has a every corner has an 10 mm radius. Okay. Let us go for corner here. Okay. Click this portion. This portion. Okay. You provide radius 10. Okay. Then select. Right. You can just move the cursor and you just delete and enter the value. You got all four corners now. You got all four corners, right? Of a radius 10. Now what is the next? Next you need to draw this portion. You need to draw this portion, okay? You need to draw this portion. So now what is the overall length? Overall length is 140 mm. So it has been placed 30 mm from the bottom surface, okay? From this surface, center position is 30 mm. Let us go for again, okay? Now you have a rectangle. Now you have an elongated hole. So now specify positions, okay? Specify positions. Okay. Then you click here. Now you need to provide the dimensions now. You need to provide the dimensions. Now how much it has to be? 30 mm, right? Then the center distance has to be 130. Okay. Now radius has to be how much? It has to be 10, right? Now it is giving some error here because it has took a dimensions here. It has took a dimensions. You need to delete it. Now it has been set. Now it has been set. Okay. Now if you are placing a dimensions more than the required, it's going to show it as a over constraint. It's going to show it as a over constraint. Next, you need to draw one circular hole. You need to draw this is circular hole. Now position is how much? It's 100 mm. Exactly, it is center. Okay, from right edge 100 mm, from bottom edge 100 mm. Now I'll go for circle here. Okay, I'll just draw. Now what is the radius? Go for dimensions. Now its radius is 20. That means diameter is 40. You just double click here, provide dimensions 40. Right? Now its position. Okay. Now it is took from quadrant point. We no need from quadrant point. We just select it and delete it. Okay. Click dimensions. You click on center point. Then click here. Okay. Now provide dimensions. It is how much? 100. Okay. Similarly, from center point to this bottom dimension. This is how much? 100 mm. Right? Now position of center hole is over. So next you need to draw the arc shape hole. Okay? So that is what cylindrical elongated hole. Okay? Cylindrical elongated hole. Now I'll click here. I'll go for a cylindrical elongated hole. Okay. So first you need to define center point. This is the center point. Okay. Next, what is the radius? It has been placed. You just observe. Now outer radius is 80 mm. Okay. Inner radius is 60 mm. Now this radius is 60. This radius is 80. Now what is the center point radius here? Can we calculate how much it is? Now it has to be radius. Okay. Now it is radius is 60 plus 10. It is 70. Okay. Let us go here. Radius is 70. Right. Now we need to start the position. So you just place here. Then you just click here. After that one, you can edit the dimensions. No problem. You can edit the dimensions. Let us go for editing dimensions now. Now I will select this one. Now it has took a radius. You just observe it is showing here also, here also. You need to delete any one. Okay. Already you have dimension. Just double click and change the radius here. 10. Okay. Right. Then click on this one. Okay. Dimensions. Now it has taken 60. It is right because you have given the radius for this pitch circle. Radius for pitch circle. So what else remains here in this diagram? So you need to provide the angle here. It has to be 110. It has to be 110. Now click here. It is giving a angle. Sorry, radius. Keep as it is. If you just double click, we'll see what will happen. So polar it is a 140 degree. So angle is 45 degree. Radius is 70. Okay. So as we need to provide symmetry, okay, as we need to provide the symmetry, now horizontal line is 180 degree. Okay, you can just understand here. So now this horizontal line is how much? This side is 0, this side is 180. Okay, right? So vertical is how much? It is a 90. So now included angle, okay, for the arc is how much? Included angle for the arc is 110 degree, right? So that means it has to be 55 degree here, okay, and this has to be 55 degree here, right? Let us see. So now it has to be how much? 45 degree or 35 degree? 45 means 45 is going to come a 90. Let us go for a 35 here, okay, right? Now similarly, you just double click on this end point, okay. So polar is taken a 45 degree, radius is 140. Wrong. Okay, now angle has to be how much? They have given a 73.18. Okay, you provide 35 here. Let us see what will happen. Now it is come here. Okay, you just undo. Okay, just double click. Okay, it's giving 75. Okay, go for 110. I think it's giving included angle. Okay, 110. So now included angle is 110 degree here. Okay, from here to here, from here to here it is 110 degree. I think it is right or wrong. Included angle is 110. Somewhere you made a mistake. Just make a practice here. Yeah, so I think it has been taken polar coordinates 75. If you want for 75, it's coming in downside. Okay. you need to check it. So whether you got a one, I think angle is more than 110. Actually, you need to get angle as a 110 degree. You just make a calculations here. Okay. So now, if you want to get a total 110 degrees, so this has to be 35 degree, right? And this has to be 35 degree. Now 35 plus 35 how much? You will go to get a 70. So rest of the angle is 110 here. Okay. So 110 plus 70, you are going to get a straight line that is about 180 degree. Okay. You just make one more time practice over this cylindrical elongated hole. Otherwise, we'll draw one more time. We'll draw one more time. Let us. Okay. So you check out. So angle is there. We provide 110. Radius has to be 70. So now this is what a center point. Okay. Radius is 70. I think which radius is taking. Okay. Angle has been fixed. 110 starting angle. Okay. So let us go for 35 the starting angle. Now it has been started. Now end angle. I think for end angle there is no any possibilities here. Okay. Now let us change the parameters here. Now this is gone for 70. Now this has to be how much? 10. Okay. Now radius of this one. Now radius of this one. Now we'll delete this one. Okay. Because it has been over constrained. Already it has been given as 60. Let us go for 70. Okay. You just check out the input parameters for the circular elongated hole. Okay. So that is why you need a more practice on these CAD tools. Now here it is an starting angle and it is the second angle here. We have not provided second angle as it has been hidden. Okay. Now it has been hidden here. We have not provided. So let us try one more time. I think you got a concept. You got a concept how to draw elongated cylindrical elongated hole. Okay, right. Now one more option is here. Use of mirror here. Okay? Use of mirror. Now I'll close this diagram. We'll go for next one. Okay? Right. Now another one diagram. I will just draw on PPT. It's a simple diagram. Okay? It is a simple diagram. I'll just draw it on PPT. It is a center line. Okay. It is a corner profile. Now the overall length of this component is 200 mm. Okay. Now it is symmetry. This is what a vertical line. Okay, this is a vertical line. It's symmetry on left hand side as well as right hand side. Now overall height is here. It is 90 mm. 90 mm. All these corners. Okay. All these corners has a typical radius of 10 mm. Every corner. This corner. This corner. This, 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 as well as this. How many corners you got here? You got on 6 corners. Sorry, 8 corners. All 8 corners of a typical radius of 10 mm. Next, so height of this portion is 50 mm. Okay. Overall height is 90 mm. Now location of this elongated hole from base is 20 mm. Center point of elongated hole is 20 mm. Now the overall length of this elongated hole is 120 mm. Okay? And width of this portion is what 40 mm. And position of this elongated hole is from base, it is 40 mm. Okay? And radius of this elongated hole is 10 mm. And radius of elongated hole is here 5, it is 40 mm. Overall length of this vertical elongated hole is 30 mm. 30 mm. So as it is symmetry about a vertical line, so you can draw either right hand side portion or left hand side portion. That is, you can draw only this much of portion. Okay. Or you can draw only this much of portion. You can draw in any one side, either left hand side or either right hand side. So now let us go for drawing the portion on left hand side. So this is what use of mirror tool. How to use the mirror tool, right? Now I switch on to CATIA. I'll go for start mechanical design, part design. Okay, so I'll go for this name as an as. Okay, go for sketch 4. I'll click on sketch workbench. I will select front plane. Now first I'll draw one vertical line here. Okay, I'll make this as a construction. I'll make that as a construction. Now what is the portion here on left hand side is from center point. It has to be exactly half length. 100, 60, 40. Okay, then height and all those things. Now you can draw the outer loop as a continuous one based on calculation of dimensions here. Based on calculation of dimensions. Let us look out here. Now I'll take this is the first point. This is second point. This is third point, fourth point, fifth point, sixth point. Okay. You got a profile, outer profile. Okay. Then you draw some center lines. You just offset them. Okay. Then you can draw these holes. Okay. Now I think we'll try whether we're going to get an exact elongated hole or not. Let us see. Okay. Right. Okay. Now we'll go for profile here. Okay. Now we'll start from this origin. Okay. 0, 0. Right? It has been started. Go for regular here. Okay. Next, minus 100, vertical 0. Okay. Next, minus 100. It is a 90. Okay. You just use tab key to switch the points or to switch the values from horizontal position, vertical position, either length or a degree. Okay. Use tab. Now I'll go for minus 60, 90. Okay. Use tab. I'll go for minus 60. Okay. Now you'll just check here this depth is how much. It is a 50 mm. That means this overall height is how much? 40 mm. It is how much? 50. Just draw one line. You got a profile. Now all dimensions are highlighted here. All dimensions are highlighted. Right. Now you can go for corner first. You can go for corner first. Corner here. Okay. All radius has to be 5 mm. Okay. Click here. Provide radius as a 5. Just double click one time. Use tab. Okay. If you're going for two times tab, it's going to switch to the input of value. Input of value. Right. Okay. I've got an outer look here. You can use trim command to remove this portion. Remove the portion. Now we need to draw what it is this vertical elongated hole and horizontal elongated hole. Now we'll go for vertical elongated hole. Right. Now provide distance. Okay, go for dimensions from this to this. How much it has to leave. Okay, that has been not provided. Height only provided. Okay. I think you need to leave 20 mm. Okay. So now this distance has to be 20 mm. Exactly symmetric. Double click here. 20. Right. Now position from bottom. Now you have an over constraint dimensions here. That is 2 times 100. Now from base point, Okay, from this point to this point, it is a 40. Now, overall length of the hole is 30 mm. Now, this has to be 30 mm. Okay, okay, provide. Okay, now from this point to this point, dimension. It's a 40, right? 40. Now, radius is 5. Now, on one vertical elongated hole is over. Next, we'll draw the horizontal elongated hole. Click here. Okay, we just draw. Okay. Now, regarding dimensions, now this has to be 10 mm. Okay, right. Now, position here. How much it has to be? 20 mm, right? 20 mm. Now, radius of this one is, that is already given. Okay. Now, length, it is 120 mm. Okay, let's come on this side. Now, let us fix the length with respect to this vertical line. It is how much? 60, right? Now, you can use trim command to trim out unwanted portion. I don't need this portion. You go for quick trim. Okay, because it has been reference. So next year, as you need to make a mirror, okay. Somewhere it is giving dimensions error. Let us delete 2 times of dimension. Now click on mirror. Okay. So first you select the elements you want to make a duplicate. You just provide an box, right? Then select the line about which you want to mirror. Select the line about which you want to mirror. Okay. So now this completes your diagram. I think we need to check some options are here showing an over constrained. Okay. I'll just click on x equal 20. Now this is a diagram. This is a diagram which is done using a mirror tool. I'll stop. I'll stop. Okay. So you have any doubts? You can just open the mic and you can
So,
discuss with me.